Hello, and welcome to my data engineering project presentation. My name is Mike Bernardo, and I'm a data scientist. In this presentation, I'll walk you through the data pipeline for my guitar appraisal app. According to the Fender New Guitar Player Landscape Analysis Survey, over the past 2 years, roughly 16 million people tried to learn how to play guitar. Now, this demand for guitars, coupled with the current supply chain issues, have created a guitar price bubble, similar to that of the housing and rental price bubble. As a guitar nerd, my desire to be able to play as many different guitars has led me to buying and selling used guitars just to satisfy that need. However, with this pricing bubble, and because I don't always have the luxury to research prices of guitars from a computer, I want to be able to estimate the value of a used guitar using machine learning from my phone. So as a data scientist, the solution is to build an app. So here's the overview of my data pipeline. There are 4 main phases. The first is data ingestion, which involves scraping data from reverb.com, which is a site for buying and selling music gear. The second phase is data processing, which involves data cleaning, feature engineering, and model building. Data storage, which is done via Amazon Web Services, S3 bucket. And finally, deployment, which is done via Streamlit Cloud. Here's the pipeline again, and I should mention that another key part of this pipeline is making sure that it all works as scheduled. So I have email alerts in place for this as well. So let's take a closer look at data ingestion. For this part, I used Selenium and Beautiful Soup to scrape the initial 130,000 guitar listings. This is what is used for building the initial model. And to avoid getting flagged or blocked by Reverb, I scraped and exported files in batches, which I later combined. The next step is to clean data using a combination of pandas, regex, AST, and NumPy. Guitar data is mostly categorical data, so it required a lot of transformations and feature engineering to prepare the data for modeling. Once the data was ready, I started building my predictive model. The model I used was a logistic regression model with price as my target. As mentioned earlier, I had to numerically encode a lot of the data. So here's a sampling of the predictions from my model based on the initial 130,000 records. To keep the data and my model current, I used a combination of Papermill and Cron to locally run a notebook on a weekly schedule. Now, this notebook will scrape the latest 10 pages of guitar listings on Reverb using Selenium and Beautiful Soup, and then the new data is uploaded to my S3 bucket. I also store the data locally in PostgreSQL via PsychoPG2 as backup. I used Bot03, which is a Python SDK for AWS, which would allow me to securely connect with the objects in my bucket and specify different IAM users to perform different tasks. My initial clean data and linear regression model, as well as the updates to both of these, are stored in the cloud. AWS also allows for versioning of these files in case I need to go back to a previous version. Updates to the model and data happen in the cloud via a Deepnote notebook. The notebook runs on a schedule, and upon execution, it retrieves the master data and update data using Bot03. The notebook runs the data cleaning and model building functions that I created earlier, and then it puts the new data and model back into my bucket, as the new versions are also tracked. Deepnote has the ability to save the executed notebook. This allows me to see if any errors happen during the execution just by looking at the saved notebook. After the notebook runs, Deepnote sends me an email regarding the status of the execution. Streamlit is used as the front end of the app. Streamlit code is pulled from GitHub, then deployed to the web via Streamlit Cloud. It pulls in my regression model from my S3 bucket and caches it. This allows the model to run against data without having to go back to AWS every time. A user can then select features like body type and origin, and the app will predict the value of your guitar. To recap how the pipeline works, I have 2 data ingestion nodes, one for the initial build of the data and a second one for any updates. Web scraping and the initial processing of the data is done locally, and the updates are scheduled using Cron and Papermill. All data is stored in an AWS S3 bucket using Bot03 SDK. Updates to the data are done via scheduled execution of a Deepnote notebook. The Streamlit app connects to my S3 bucket for the latest model and allows the user to predict the value of a guitar. Finally, Here's a URL for the live app. I have the app running in an iframe of my presentation. So for this demo, let's select the Telecaster, a semi-hollow guitar in very good condition. We click on this, and voila, we have a price prediction or a price appraisal. Thank you for watching my presentation.